Awesome. All right. So, welcome to today's Tuesday session of Delta Evening and Weekend Platoon. Hopefully things are going relatively well. I know you guys have your third assessment coming up very shortly here. So the game plan for today is going to be, we're going to discuss a little bit about HTTP, which I know you guys played with a little bit last class. And then after that, Chad's going to have a mini review lecture on SQL, again, for the assessment purposes. And then after that, we have a interesting group challenge. So before we get into my lecture for today, which will be a little bit on the shorter side, does anybody have comments, questions, concerns, things of that nature that I can answer before we jump into things? Okay, if no one has anything, would anyone just like to summarize very briefly what you all did last class, or if you have any questions about the material that was covered last time before we jump into the slightly newer stuff?
So yesterday or last night, we went over Perl and then get, post, stuff like that for working with APIs. And then we went over a few different types of software that just allows you to kind of read your GET requests and your POST requests a bit easier.
Okay, sweet. Yeah. So the GET and POST and those other requests that you can make, those all operate using something known as HTTP, which is sort of like the underpinning of the web. So all the stuff that, like, when you log on to like your computer and open Google for the first time, your computer basically goes and pings a server somewhere, which then returns something. And the something that it returns to you, as you guys probably experimented with, is the HTML code of the Google website. And this happens for literally anything that you do on the internet. If you will type a key, or if you like enter a search query or click a button or whatnot, it will ping a server. That server comes back to you and tells you the result, which is how we get websites and websites updating and stuff like that. So today's lecture is going to be a little bit more detail on how this works. So let me go ahead and find the slides. Share screen, HTTP. Awesome. All right. So hopefully you guys can see what's on my screen.
Yep.
Okay, sweet. So let's go full screen. All right. So HTTP, the thingy that controls all the stuff that you guys did last time, and basically anything we do on the internet. So what is HTTP? Hypertext Transfer Protocol. And this was originally described in 1991, which was a decent while ago, but the origins of HTTP date back to 1930. So it is a really old idea that is, just like a lot of old ideas, only been recently executed, which is kind of fun. So hypertext transfer protocol was originally designed, again, as it says, is as a protocol for transmitting hypertext. And hypertext today is basically HTML, which is just hypertext markup language. So a lot of the acronyms that we'll see do end up relating to a lot of these older concepts from early versions of the web. But again, as it says here, today, HTML does a whole lot more than just hypertext and linking one page to another. But having links between different pages is and was, and I suppose still is, a hallmark of the internet, that you can jump from page to page, which is great. Also, you can use HTTP to transfer not just HTML, but any type of document or file. And later on, we'll probably get into file transfer protocols and secure file transfer protocols, which are way cooler. But that's something for later. But basically, HTTP is part of a decent subset of transfer protocols that we can use to get information from point A or computer A to server computer B or whatnot. And as it says on the bottom, you can transfer a ton of different stuff using HTTP. You can transfer images, CSS, JavaScript, API responses, like the stuff you guys were doing last time, and a ton of other things. So how does HTTP work? So we've got two parties in any interaction here. We've got a client and a server. And this very, very coincidentally is known as the client-server model. So the client sends the server a request, and the server sends a response back. So like if I go to Google and I type how to program that, and I hit the enter button, the how to program basically is embedded in my request that goes to Google's massive giant server. Google runs some algorithm on the server to give me some results, but the results are only stored on the server. Or to get those results back from the server to my computer, the Google servers have to send my computer a response with the millions of browser entries about how to program, for example. And this is a wildly simplified version, but that's basically the way that HTTP and getting, oh, that was weird. Okay, there we go. I have no clue why that just happened. But that's basically the way that we can get information from a server or send it to a server. So HTTP requests are things that we send to the server. HTTP responses are the things we get back. And as stated here, both the requests and responses are plain text. You guys saw this last time, and they can be read super easily by a human, or if you want to create an interpreter for them that translates it, you can do that. And they all have pretty relatively simple structure. So here's an example. So the first part is the type of request. So this is going to be a GET request. And it wants to get the file called bio.html. And then it wants to use the HTTP 1.1 protocol. So again, as it says here, the request line, this real quick. It's going, the first thing is the method. So just like you have post, you have get, you can do update, read, etc. The next thing is the URI, which is the place or the thing that you want to get from the server. And then the HTTP part is the protocol version, which is Hypertext Transfer Protocol version 1.1. And again, there are a bunch of different HTTP things that we can use. You guys will learn more about them as we get into the later units. But a lot of time you want to use like get something, post to push something up, put in order to add, and delete in order to, well, delete. All right, so next is the URI, or the Uniform Resource Identifier. This is really similar to a URL, but it's basically of a short part at the end of the URL, and this specifies exactly what file we want to get. And then also there are a bunch of different uses for URIs. So yeah, so URN has the host plus the URI, but then the URL also has the protocol. So again, HTTP, remember, is file transfer, is our transfer protocol for hypertext. So we put that here. Then we put the host, and the host site here is example.com. And then the URI, which is the thing we want from the host, is bio.html. All right, so next up, we just talked about the request line, but now we need to talk about the headers. And the headers basically tell us where this, it gives us more information about the request. So for a header, for example, you can specify the host. You can say, all right, bio.html, that's great. Now I have absolutely no clue, if I've just read the first line, where to even find bio.html. Where can I find it? I can find it at the host, which is example.com. So then that says, okay, I know where to go. I know where to get this information from. Then the user agent basically just says, here is information about the machine that is sending this request out. You can also add in content type. And also in the headers, something that we'll learn later is how to add headers. So for example, if you have, let's say, a web page that is password protected, and you need to get information from that password protected web page, you can put in like a username and password or something to that extent within the headers in your HTTP request that when you send it to your server, that server can then authenticate the request and approve the request based off of making sure the username and password combination is correct. And then lastly, we also have a body, which can have different things. You can add in queries, and you can put in image uploads, you get forum content, you can change code, etc. So this is like the 101 of HTTP requests. Before we move on, does anybody have questions or comments, concerns, things of that nature? And also, if I'm moving a little, oh, go ahead.
Oh, sorry. When a request doesn't have, like, say, a header, is that like a security threat or something?
Not really, but you basically always need a header. So again, so here the header tells us the host, which is really important because otherwise, if I just said, like, going back to this one, get bio.html, and I just like sent this request, HTTP protocol does not understand where, or the server that I'm sending this to on the other end. It's like, okay, great. I get that you want bio.html, but where do I find this file? Because there can be 1,000 different hosts that have a bio.html. And it's like, I don't know which one you want. So for that reason, having a header is really important in order to like further direct that HTTP request, if that makes sense. But that's a good question. And also, yeah, on the note of security requests, though, that's where some things like the user agent content type, and you can add in as many headers as you want, basically. And that can help you alleviate some of those security concerns. Any other questions about HTTP requests before we proceed? All right, if not, we should also talk about query parameters. So I go back here. Remember how I said that the query down at the bottom is going to be in the body? Well, in the request, we can also add the query in here by adding a little question mark and putting the query after. Now, something fun. Have you guys also seen question marks in links that you put into the web? For example, like if you're looking for something on like Amazon and you come up with like a product and you click the product, it'll have like amazon.com/ and then like the product name and ID, and then I'll have a question mark, and they'll just have all of these random like numbers and things with like letters and equal signs. It doesn't make any sense. All of that stuff are all individual query parameters that Amazon or Google or other sites have in their HTTP requests and responses that come back to you. So that's what a lot of that part is. And the queries are basically, again, just like your SQL queries, they're things that we also want in addition to just sending out the simple request. All right, so also going back to Kasib's question about headers, we have a couple of different types of things we can include in our headers. So the first one here is the host, which again, as discussed, is basically saying, hey, where do I want to get stuff from? You can also put in like a language that you'd prefer the response be sent back in, the type of client that sent the request. So for example, if you have like a web page that looks better, that you have like a different setup for on mobile versus like on a computer, knowing the user agent is really helpful because if you're on mobile, you don't want to get the same like normal laptop configured web page. You want the one especially for mobile. So knowing user agent is really helpful for that. And then lastly, also what format of response do you want? Do you want it in plain text? Do you want it in HTML? Do you want it in another format? So headers can help us with all of that. All right. So are there any questions about headers before I move on to responses? Okay, if not, so again, going back to the format of a request, we have the request line, the headers, and the body. And that's basically all we ever need in HTTP requests. Now, the response is eerily similar, which is great because then it means less complications for us. So the first thing that we have instead of the request line is the status line, which has some similarities and some differences. We'll talk about that shortly. Then we have the header for the response. And then we have the body, assuming that the response needs to return anything. So let's start off with a status line. The status line just has a couple of parts. The first thing is a status code. And these relate to all of our conventional errors. Just like the famous 404 error, you can get 402, there's 200, etc. And there is a fantastic web page that has all of these error codes along with corresponding cat pictures that I can send once we take a break. If you're inclined to learn them all, that is something that I can highly encourage you to use. So after the status code, generally comes a little bit of English that helps to explain the status code in case you don't feel like looking it up at that time. For example, 200 is everything's good. And as it says in the reason phrase, okay. And then after that, just like in our request, we have the HTTP or the type of transfer protocol used. In this case, just like usual, HTTP and the version 1.1. Next, we've got the response status code. And that, again, as part of this, tells us the result of the request. So it'd be like 200 is okay, 400 bad request. 401 is if you're unauthorized, like if there's, again, something with the permissions that you haven't set. 404 is not found. 500, which is usually pretty bad, is an internal server error, and so on. So if we go back to the response headers, again, these are real similar to the request headers. And the first thing that we have is the content type, which most of the time is going to be HTML or whatever you set. The next thing is the length, which is the number of bytes in the response body. Thirdly, we have the cookie. So if a client saves a cookie, then that tells us what the cookie is. And then lastly, it just tells us when the response was sent. And you can put in more response headers if you want. There are tons of them. These are just the fairly common ones that we use. All right, so basically, their HTTP, as you guys have seen from yesterday's class, I'm sure, is used a lot. And it's used for literally anything that you do. Whether, again, as it says here, loading the HTML. After you load the HTML, you have to load the CSS. After loading the CSS, you have to load the JavaScript. And in the middle of all of that, you have to load the images and the buttons. And if there's like an embedded form, and basically, there is a lot of HTTP stuff that goes on in the background. So it is super important for us as programmers. We've got a couple more slides here, and then we can pause for a couple of minutes. So one thing to note about HTTP is that every conversation, again, we have like a bunch of simultaneous conversations happening here when each of these take place. Now, each of these are different from the other, and they all start with new connections from the client to the server. So loading the HTML is going to be different from loading the JavaScript, which is going to be different from loading the CSS, which is going to be different from loading the images, and so on. And then lastly, another thing to note is most servers will automatically clear all the state variables with each request, because if you keep all the variables for every single request, you're going to have a lot of your storage and memory being taken up by variables that were used by old requests that just are now sitting in your computer. So it's easier to just basically clean out the variables every time, which means, coincidentally, since you guys are going to be writing your own requests, every time you make a request, you kind of need to put the variables back in every single time, which can be a little bit annoying and something that you'll have to automate. But again, that's just the way the cookie crumbles. However, this is where cookies come in as well. So cookies can help us basically keep some things in memory. So again, if we look at like browser storage, for example, browser storage and cookies go hand in hand, because that helps us know about, for example, who logged in, what was their last search, what did they look up in their browser history, or for example, if you set like your age on a website, if it's like an age restricted website, or like you have to like before like hitting the purchase button on something, you have to enter your age so that, or something like that. Then the browser saves that information. So that way the next time you go to that website, it's like, okay, yes, I know this person's age, blah, blah, blah. Let me just verify that that is accurate with what the site wants, and then we can keep moving or stop. So cookies kind of bypass the statelessness of it. But again, this goes a little bit outside of HTTP, the protocol itself, and more how cookies actually work. So the way that cookies work, the server sets your cookies by sending them to the client. as part of the response, again, not the request. The client stores the cookies, like your browser. The server, like the big Google, like server units, do not store your cookies. And any cookies for the current domain are sent to the server as part of our request. Okay, so wrapping up the HTTP stuff. It's a hypertext transfer protocol. It has worked for a long time. It pretty much works most, if not all the time. It's relatively simple and easy to read as far as code goes. And it's used pretty much everywhere. So that was HTTP 101. Does anybody have questions, comments, concerns?
I guess more of a comment than anything. You said HTTP was around since the 30s. Is that right? How the hell did that happen?
That is a good question. So the actual protocol itself was enacted like in code in the 1990s, but I guess people probably just came up with the idea for HTTP back in the 30s. So the 30s and 40s were a really interesting time for a lot of the early like computer science theories to be developed. So for example, if you look at like the earlier research of Alan Turing, a lot of his stuff through World War II was about like the foundations of artificial intelligence. And like a lot of early graph theory and communications theory work was done that would basically make up modern information theory. And all of this stuff was happening at a time where they were literally using like typewriters. So basically they came up with these super advanced ideas, but they just didn't have the technology to create them until like 50 or 60 years later. Any other questions? All right, so real quick, and then I'm going to turn things over to Chad because he has a helpful lecture for you all today. I'm just going to run through the HTTP network diagram. So can you guys see my screen okay?
Yep.
Awesome. Thank you, Stephanie. All right. So basically going into a little bit more detail about the client server model, which is what HTTP relies on. This is a kind of complicated diagram showing how everything goes together. And again, this diagram is based off of the Python socket module, which basically lets us interact with HTTP using Python, which is pretty nice. So we set up sockets, which are communication endpoints for both the server and the client. Here, let me zoom in a little bit. And then after that, we have to bind the socket. Again, going back to this table, is attaching a local address to it, which is sort of like the letters with dots or the numbers with dots that you'll see if you type in what is my IP. It's relatively similar to that. Then after that, we're going to say, all right, socket, I'm going to be willing to get requests, which is where listen comes in. And then after that, accept just means that we can basically wait for a connection attempt from the client. And then we wait for the connection. So all the client does is it sets up the socket, this communication thing. Then it connects to the server that has a lot more stuff in the back end. It sends a request to connect. Then the server says, hey, I got a ping. All right, I'm going to connect to this client. And then after it's established a firm connection, the client then sends its information in the HTTP request using send, which then coincidentally gets received by the server. The server processes the request, and that's going to turn that request into an HTTP response, which it then sends back to the client, and then the client receives it, and we're done. So basically, client and server both set up socket endpoints. The server has to do a little bit of finagling in the background in order to like set it up as a server socket and make sure that it can accept requests from clients. Client sends a request to connect, the server approves it, the client sends over its HTTP request, the server receives it, flips that around into a response, sends that response back, and the client receives a response. So I'm not sure if this flowchart is too helpful in terms of conceptualizing it, but if you guys will look at your challenge for today, which is HTTP server 1, you're basically going to build an entire HTTP server using this Python socket library, which uses the framework that's in the slide, in the main page on the previous slide. So hopefully that will help a little bit there. But basically what we're going to do here is practice our OOP skills, practice using the socket library, which is actually pretty cool. And again, this goes into a lot more detail about what it wants you to do. But for right now, they want you to basically download the server.py code. They want you to run this code. And then after that, use curl or postman in order to make requests to this localhost server and edit the code a little bit in order to get it to actually display the stuff we want and be more useful as an HTTP server. So that's going to be your group exercise for tonight, which we'll do in a little bit. But do you have any questions, comments, concerns? I know I went through today's material kind of quickly, so if anybody does have any, please feel free to speak up. All right, if not,
All right, can you see my assessment 3 review window here?
yep.
All right. All right, so the previous example we did, we modeled the library. So this time we'll do something slightly different, but same basic idea. So let's do like a blog, Yeah. So in this blog, you have users, and then users can create posts, and then those posts can have comments. So users can also comment. And then you can also like a post or a comment. Okay. So if we have a blog, so I'm gonna kind of make some assumptions just to speed this up a little bit. But as you're thinking, you're gonna want to model the problem and then try and think about the entities that you need. Once you have those entities, you're going to try and figure out what relationships those entities are going to have with each other. And then once you have that, and of course, while you're doing this, you're hopefully diagramming things out. And then once you have that, then you start writing the actual SQL. And then as you write SQL, you can, of course, come back, and modify your original plan. But so we've got a blog. And the entities that we have, we're going to have users. We're going to have blog posts, and we're going to have comments, and we're going to have links. Okay, so I'm going to take these entities, since I've kind of fast forwarded through actually figuring out what these entities are. And I'm going to go here into the visualizer of my choice here, and I'm gonna just copy all that stuff down. All right. And I got my users, I got my posts, got my comments, and the likes. Okay, so let's start figuring out what the relationships are between all these things. So a user and a post.
The user can have multiple posts,
Okay, good.
many
Yeah.
posts.
Yeah, so a user can have many posts. And what about the reverse relationship?
A post will only have one author or user if we
Yeah.
look at it that way.
Yeah, yeah. So yeah, I think that's good. We could potentially change that. You could have multiple, multiple authors. But yeah, we'll stick with a one-to-many there. So I'll give this a primary key. I'll give all these a primary key. And then how are we going to express that one-to-many relationship between users and posts? So how do you express a one-to-many relationship in SQL?
You need a foreign key in the table that has the many.
Yeah, so we definitely need a foreign key. So if there's a one-to-many, then we're gonna put the key in the thing, basically the owner. So if the user owns the posts, then each post gets marked with the user, basically. So here we would have user ID. So I'm not sure. Yeah. Let me change the name of this. Let's see. I'm not sure why this is giving me trouble here. Oh, it's a foreign key. That's fine. Okay. Cool. So the users and then the posts. Okay. So now I have, again, this is kind of standard notation, but you don't have to know this. But so the way you read this is you go from blog users to posts. That is many. So there's three, the crow's feet there, the three-prong thing means many. So I go from users have many posts, and the reverse, going from posts to blog users, there's just a single line through, so that's a one. So posts, a post belongs to one user. Okay, so that's good. What about blog users and comments?
Would you just do the same thing? One user would have many comments.
Yeah, I think that would make sense. So users can, a user could write a post. A user could also write a comment. So that's a one-to-many. So move this over here. So again, a user can have many comments, and a comment can only belong to or be associated with or be owned by one user. Okay, what about likes? So what's the relationship between a blog user and a like? If there is one.
I mean, I'm still thinking it's the same. It's the one to many.
Yeah, I mean, I think so. So you know, it makes sense for a like to belong to someone. I mean, you don't necessarily have to do it that way. You could maybe do like some kind of anonymous like, but that might be more of like a front end, like not showing that on the front end. Probably you would want to know that you have a user making the like. So yeah. Okay, so it just so happens that everything is connected. Everything so far has a one-to-many relationship with the user. Okay, so we've done like blog users, users posts, users comments, users likes. What about some of these other relationships? What about posts and comments?
So would they all be many to many? Because you'd have many posts would have many comments. Oh, well, no, because I guess many comments would not have many posts. So then maybe just one to many as well.
Yeah,
One post has many comments.
yeah. So the initial thought of it being many to many. So that, I mean, that could potentially work if you had you know, a comment could belong to many posts and a post could have many comments. That might be something like if you had a table with like a limited like ratings, for example, if you could only rate something from 1 to 5. If you have a limited set, then you could do something like that, because you know, like the rating 1 could belong to many posts, and a post could have many 1 ratings, for example. But because comments are probably going to be like unique, basically, so every comment is potentially, you know, unique. I don't think that the many to many would work there. So I think probably a one to many here for posts and comments. Okay, so what's the directionality of the relationship here?
The comments would get the foreign key, right? You would do post under comments, you do post ID foreign key, and then the greater
Yeah.
than dash.
Mm-hmm. Yeah, so we would say that a comment belongs to a post, right? Foreign key. That will be posts.id. So a comment is really kind of owned by a post. That wouldn't make sense to have, you know, an independent comment, you know, a comment without a post being associated with it, which I guess would kind of make it a post. So yeah, so a post can have lots of comments, and a comment is associated with 1 post. And by the way, we're talking about, you know, we haven't really done a one-to-one example, which is fine, but one-to-one, many to one, and many to many. So these are the 3 basic categories. That's all you really need to worry about for now, but just FYI, that you can get finer grain. So it's not just one to many, but, you know, 0 or 1 or 1 to 3. So depending on your application, you might, you know, you might end up being more specific. So for example, posts and comments, like could a post have 0 comments? Yeah, I mean, that would make sense. You could make that decision in your application, but so the relationship would really be like 0 or more, or 0 to n. But that's kind of a finer point you don't need to worry about, but just as background. But you should think of these in terms of the general category of, you know, one to many, many to many, basically. Okay. Posts and comments. What else have we not done? What about likes? So we know that likes has a relationship with blog users. What about posts and or comments?
Seems like it's linked to everything.
Yeah, I think yeah, we could a post can have a like, a comment could have a like. So this is a little this is maybe a little weird, but so we did something like this where we have let me just do posts. And I got user. All right, so it's starting to get a little tangled here. But if we maybe that's okay. So likes here. So this has basically a relationship to everything else in the table, but a given one, there's kind of no such thing as a like, basically, in the database. A like is just expressed by the fact that there's an entry in the table, basically. Kind of like an order, right? If you have you don't mark something in the table that has is an order with Boolean or something. You just have a table that connects a user with some items, and then that row has an order ID, and that row represents an order, even though on some level it's not, that entity isn't like directly represented. Okay, so we have likes here, and then in terms of the optionality, you can see that any given like is probably just going to belong to either a post or a comment, right? So there would always be a user, because the like should always belong to a user. So that relationship would really be one to many. But post ID could be 0, could be 0, could be 1. Same with comment ID. So for any given like, one of these is going to be null, basically. Okay, so I think maybe this is enough to get going. So I'll take a screenshot here and come in here. All right, so we have our basic sketch right now. Let me split right. So I'm gonna go ahead and start writing the SQL for the schema. Okay, so I'm gonna, just for the sake of convenience, I'm gonna add all the drop table stuff so I can rerun this, because I'm gonna make mistakes. So drop table if exists, log users, cascade. So what is cascade for?
When they have those relationships with the foreign keys.
Yeah, so you don't create orphan records. Okay, so blog users and comments. Likes. So just one thing to keep in mind as you're as you're doing this and on the assessment as well, you have to be careful about keywords. I think user is a keyword in SQL, or at least don't call your table user or users, because it won't work, and you're not going to get an error message telling you that. So just keep that in the back of your mind. Try to give things names that aren't going to be keywords or other tables that already exist. Okay. All right. So let's think about, as we're doing this, basically, I'm going to try and do this from top to bottom. So we want to keep an eye on dependencies. So the first table I write should ideally not have any dependencies. So what table fits that bill?
It's the blog users.
Yeah, I think so. So we'll do create table, blog users, and then we describe it. So ID serial. Again, I'm going to let Postgres handle this. Primary key. And then I'll just do a name. Or maybe email. Okay. All right, so I think that is good there. I got a colon, and I'm gonna create my next table.
There'll be comments.
Okay. So what dependencies does comments have?
Oh, wait a minute. There's one for likes
Would you do post next?
and posts.
Yeah, I think post would be the next one. So post only depends on users because it has a foreign key relationship to blog users. So create table post, and then ID serial primary key. So it doesn't matter if they're caps. Like ideally, I think the SQL stuff would be in caps, but who has time for that? Okay, so we've got the ID and then user ID. So that's a title just to represent that varchar. So again, I'm for all these models, I'm doing the absolute bare bones just to get something up and running. But you'll want to think a little bit about what a post should have. For the purposes of the assessment, don't go nuts. Don't make like 30 fields or anything like that. Just keep it mildly realistic, but the least you have to do in order to achieve that. Okay, so title, and then we'll have user ID, and that we'll just define that as an integer. And then on the next line, we'll say for the user ID references. And of course, like during the assessment, it's open note, so you can look up if you forget the exact incantation here, you can look that up. ID. Okay, I think that should be good. And then what's the next table I should make?
I think comments are next.
Yeah.
They're two dependency.
Yeah, exactly. Table comments, and that'll be ID serial primary key, and then comment. I'll just call it content, and then we'll do user ID, and that's an integer, and post ID, and that is also an integer. So why is user ID an integer?
Because that's the ID from the users table
Yeah, exactly.
or the blog user.
So the user ID says, and this will be blog users ID, foreign, and post ID references posts.id. All right, semicolon, and then the last one, likes. So create table likes. ID, serial, prime key, and user ID. I'm just gonna copy this. I think we've seen me type this enough to get the idea. So user, post, and comment. All right, give it a once over. Anyone see any obvious errors here?
Should we also specify which ones are not null?
Yeah, so you could definitely do that. I
For the
would,
assessment, for sure, no.
yeah, I wouldn't necessarily worry about that for the purposes of the assessment, but yeah, you could definitely do that. So primary key is always going to be not null by default. That's just part of the package that you get when you use primary key. Here, user ID, I think we would probably want to make this not null because the like should always have a user ID, but post ID and comment. So you can also, you know, you could mark them as either null or not null. You can also give things default values if there isn't something supplied. So there's, you know, you can also do like more advanced constraint checking. So we're not going to get into that right now, but
Because like when you insert into columns and values, then if it's null, which it is basically by default, isn't it? And
yeah, if you
don't you have
don't,
to write null there inside the values?
you
If
yes.
you want it blank, if you want it
Yeah.
blank. Yeah,
Yeah.
okay.
So it also depends on the field. If you just provide let's say we'll see this.
Okay, yeah. I just a little confused in some examples. I just wanted to see. But
Yeah. So
yeah.
we'll see an example, but just as a preview. So if you supply, say, you know, this just one of the column names, then you only have to supply one value and the rest are nulls. If you say insert into and then you supply all three or, you know, all of the names, then you have
Then you
to
have to put them on. Yeah.
say null. Yeah. Okay. All right. So let's run this and see if it blows up. So first off, I'm going to create a database. So create DB and we call it blog. Does that exist? Okay. Drop DB blog. Okay, so I've created a database called blog, and now I can insert these tables, or, you know, create these tables inside of it. So PSQL and then blog, that's my database, and then -f flag. There's a few different ways you can insert values, but this is how I'm going to do it. And then schema. So I can run the script inside this database. It looks like I didn't get any errors, so should be good. I can test that out, PSQL blog, and I'll just describe, and I can see all this stuff. So I'm going to say that's good. I could do more thorough check. I could describe blog users. I could describe all these. You can see all this stuff. So comments, constraint, blah, 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 foreign key, user ID, references. So here's where we're getting all of the foreign keys. Again, this is purely FYI. The index, when you create a primary key, you're also creating an index is almost like a lookup table for your table. It's kind of another table where its lookups are very quick. So you put indexes on fields that are frequently used to find information. So you don't need to worry about that, but just in case you're wondering what all this stuff is. Okay, good. So let's get out of here. All right, and let's start inserting some data. All right, I'm going to switch my view to the schema over here. All right, so to insert data, we kind of have to follow the same. If I try to insert, if I try to create a like right off the bat, I'm going to have issues because, these foreign keys won't actually exist yet. So I'll start the same way. So insert into, and then the database name, blog users. And then here's where I'm going to say what columns I want. So in this case, email. So ID comes for free. So I don't, I shouldn't specify it. I think you can and it'll override it, but you shouldn't do that. You should just let Postgres handle it. And then we're passing email specifically, and then values. And here's where we're gonna basically create all of our rows. So bob@email.com. And then let's do Shannon@email.org. And Tyler at free.biz. All right. So we'll just do 3 users. So I would say in terms of like creating data, so using Scicop G2 to do this, I wouldn't really recommend. It kind of adds an extra layer of complexity that you don't really need. But if you do choose to use it, one of the nice things about it is you can use other Python libraries to generate a bunch of dummy data for you. So it's real easy to create, 1,000 rows or 10,000 rows or whatever. So yeah, something to keep in mind here. It's very tedious. It's very tedious to do this. Okay, so blog users posts now. So insert into posts, and we will do ignore ID. So title and user ID. Okay, so this is also a case, the user ID. I think this is an example where we would want to have a not null constraint, because you don't want to have an unauthored post or an anonymous post, but we're not going to worry about that. Values, and the title will be, I'm just going to be boring, so post 1, and that is by person 1. Post 2 is by person 2, post 3 is by person 3, and then let's bubble up a couple. Post 4 is also by 1, and post 5 is by 1. All right, so comments. Insert into comments, and we'll have content. And for that matter, we probably want, content, for example, or title to also be not null. Probably want to enforce having a title or content for a comment. So user ID and post ID. Okay. Values. So that sucks. And user ID 1, post ID 2. That's from user ID 2, and that's for post 4. And then we'll just that looks misspelled, but oh well. Okay, this is, so let's say user 3, and that's post 4, and user let's say user 3 does a lot of commenting. User 3 post 1, user 3 post 2, user 3 post 4, fine, and then user 2 post 4, and then user 1 post 3. So this is going to cause a ton of confusion for me later when I'm trying to connect all these numbers to things, but all right. And likes. User ID, and then post ID and comment ID. Okay, values. So user 1 likes, let's say the second post, and then we'll create null there. So because I want to reuse this structure, I'm going to say that I have to define all 3 of these. So
Yeah, okay, that's exactly what I was talking about. Thanks.
okay, so and then let's say person 1 also likes the 3rd post, and then person 1 also likes the comment ID 2, and this will be null. So this is the most confusing part in my opinion. Let's say person 3 likes comment 5, and then person 2 likes comment 2, and 2. Okay. Okay, so validating that the queries are right is going to be a little bit of a pain, but I think this should be. Let's see if it works. So PSQL, and then the database, which is blog -f, and then data. We'll run the script, and we get an error. Okay, so error column. So what obvious terrible thing have I done that I always do?
Oh, double quotes.
Yep.
Oh no, there's a lot of them.
Okay, so sometimes regular expressions make a friend here. I think that hopefully clears it up. Okay. All right, so that works. So let's go ahead and write some queries. All right, and for that, I'm going to pull up the Yeah, I'll leave the data over here. Put it on the bottom. Try doing it like that. And let's get query.sql. All right. Yeah, so let's start with some simpler queries. All right, so let's just get all of the let's get a count of our users. Got a column, people. Let's see. Ray, how can I get a count of all my users? How many users do I have? Is Ray there? Perhaps not. What about Tim? Are you there? All right. Let's see. Pick on someone here. Chris.
There are 3 users, right? I mean, based
Yeah.
on the number of email addresses there.
So we can tell that here, but we could imagine that we have a database with billions of rows, and we can't really just look at it and count.
I
Well,
think I'll,
so sometimes it's good to start with what like a more general version of the query, and then work your way up to the specific thing. So if I want to know total users, well, maybe I'm not sure how to do that, but how do I see just all of the users? Just every single row.
my brain is
Star.
yeah, put a star.
Yeah.
Oh,
so
I
select star,
star
and then from where?
blog users.
Yeah. So I'm going to run this query. And here is my result. So I've just got, I'm pulling down everything in blog users, which is great. And I can see that there are 3 rows. So I can, of course, know that there's only 3, but I could also have some unknown billions of rows. So now that I can see that, is there a way to get the count?
Select count and open close parentheses.
Exactly, yeah.
Asterisk.
Okay, so select count from blog users, and then I get 3. And let's say I want to be more specific. So count is kind of generic. I want to show that this is the count of you, that this is total users.
Just say as total users right after count.
Yeah, as total users, like that. And then when I run it, okay. All right, so that's all the users. Let's see. What if I want to get the user who's written the most posts? But actually, so first I want to see all the users and how many posts they've written. Or yeah, so there's two ways to ask this question. Maybe I can show you both. So let's say for all users who have, it's a little wordy, have written a post, show total number of posts. Meaning if Bob wrote 3 posts, then Bob 3. If Sally wrote 1 post, then Sally 1, and so on. So on one table that has, one column that's going to be all the users that have written posts, and the second column is going to be the total number of posts that each of them has written.
Will ID be okay, or do you need also the email of the user?
So that's a good question. So, as we're thinking, so, it's easy to get kind of overwhelmed when you get a question like this, like what is going on? There's so many things, but try and, break it down into smaller steps like every other programming problem. So the, first question might be something like, what tables am I going to need to access?
The post.
Okay, so I'm going to need posts, right? So I'm going to need posts. Let me comment this. So I'm going to need to access posts. And are there any other tables that I'm going to need to access?
Users? I don't know why. My brain thinking maybe users, but
Yeah.
probably wrong. Okay.
Yeah. Okay. So it kind of depends, right? So there's a way to do it just using posts, but we won't be able. We'll just have the user ID. So if that's good enough, then that's fine. But let's say we want to show. So let me clarify this question, or change the question on you. For all users, blah blah blah. Show total number of posts and user email.
So we'll need blog users too.
Yeah. So we could kind of get at that question just using posts. But if we also want the email, well, we're going to have to grab blog users as well. Okay, so we know we're going to need 2 tables. So how do we get 2 tables in SQL?
Join.
Exactly, join. So we know we're going to need a join. So we're just like getting some, pieces of information. We don't really know what the query is yet, but we're just trying to like, pick up the pieces of the broken mirror or whatever. So post blog users, we're going to need a join. How are we going to join these 2 tables? How are these 2 tables connected?
The foreign key.
Yep. Which is
Blog users.id and post. And yeah, the ID from blog users and users ID from post.
exactly. So we're gonna have to join. We're gonna have to join them on blog users ID, where that is the same as the posts user ID. So that's how these tables are connected. If you want to line them up, you have to line them up by the user ID is the same, or sorry, it's posts. Yeah, the user ID is the same as the ID. Okay, so we know we're going to need to access two tables, which means we know we're going to have to join them. And we can look at the tables and figure out how we have to join them. Okay, so we're going to have to join them by ID. So again, as like an initial query, we could just get everything, right? So we know that the information is going to be a subset of both of these tables put together. So we can just do that first as a sanity check and maybe help us get our bearings. So let's do that. So how can I write a query that will join both post and blog users?
You would you could like select the email
Okay. Right.
and
So that is correct, but for now, I just want to be even more general.
oh, okay.
We'll just grab everything.
Just grab everything,
I want
yeah.
to grab everything and then we'll refine it from there. So select everything. So it really doesn't matter which table we start with. So I'll just select everything from post. And how do I join this other table?
Join posts on your
Yep.
list over there with IDs.
Yeah. So join.
I think it's posts, plural.
Oh, thank you. Users on blog users on posts dot user ID is the same as blog users dot ID. And just by the way, it's very, very common, basically standard practice to alias tables. So you'll often see things like as P, and then instead of posts, you would do P dot. So just FYI, you'll if you're looking at SQL, you'll almost always see the tables be aliased, but I'm not going to do that right now. Okay, so I think this is going to grab us everything. Let's see what that looks like. Okay. So we have 1, 2, 3, 4, 5 posts and 5 rows, so that makes sense. Okay, so we've got all the posts and then the authors are joined to that. So we can just do a quick sanity check. Who wrote post 1? Well, that's user 1, which is bob@email.com. So that looks right. Okay, so now that we have everything, let's go back to our question. So for all users who have written a post, show total number of posts and the user email. So again, because we have such a small data set, we can do this by hand, but we're not going to rely on that. So our final data set is going to look like bob@email.com and then count of 3 and so on. So so this is, not really intuitive, but what we want to do is get the count of every row here and then group that by the email. So we want to aggregate some information, right? We have all these rows here, and but we don't want our final product. We want the final product to have fewer rows, and we want some of those rows to be kind of combined together in some way, right? So that's what the aggregation is. We kind of like, we want all these, like these 3 rows that have bob@email.com here. We want these 3 rows to be kind of smashed together into one row. And we want that smashing to be counting. So the way we combine them is by counting. So at the end of the day, we have 1 row instead of 3.
I mean, to not have repeated rows, you just do distinct. I'm not sure, you counting the email? Or are you counting?
So we're counting how many blog posts each user has written. So Bob has written 3 blog posts, Shannon's written 1 blog post, and Tyler has written 1 blog post.
I would say probably select count email. I don't know.
So we could do that, but then we're just going to get count of email. It'll be 5 because there are 5 rows here.
Oh yeah.
Would you do select distinct email?
Okay, so that's a nice idea. That's also wrong, but that's a nice idea. So distinct email will get us partway there, right? It gets us each individual email, so that's part of the answer that we want.
Or
User
is it
ID.
where email is more than 1?
So the
No
real trick here, have you guys used group by in any queries?
Yes.
Yes.
Yeah.
Okay, so this is something which requires a group by.
We have 2
So-
columns.
Yeah, so group by kind of takes 2 things. You need 2 things in order to get a group by to work. One of them is some kind of aggregate function, which is gonna smash rows together in some way. And the other is the kind of the rock, the steady thing that is going to hold all of those aggregated values. So in this case, we want the email to stay the same, but we want the count to be aggregated. And so our final result is going to have 2 columns. One of them is going to be email, and the other is going to be a count of basically the row, because each one of these rows represents a blog post written by a user. So we're going to do select email and count, blah, blah. We're joining the tables. And then we're going to do our group by. And we're going to group by this thing which we want to be our rock, basically. So we want to see the count by email. Group by email. Let's try that. And you can see here that we have each email, and then all of the other information has been compressed into count. So the 3 rows that have, Bob got compressed and counted as 3, and so on. So it's grouped by, you take the count, you basically like group everything, and we're grouping by emails, right? Because we want, per email, we want X per email. So we take all the emails, and then we just count how many rows, and then, okay, 1, 2, 3 for this email. Okay, 3 goes there. How many for this one? 1, 2, 3, 4, 5. Okay, 5 for this email. 1 for this email. 1 goes over here. So it's definitely, not, it's not exactly intuitive, but that's how you do it. Are there any questions about that?
Just a confirmation. So essentially you can get, even though email is not in posts, you can grab email because of line 8. You have that bridge.
Exactly. So we've
Okay.
joined these two tables together. So that's how we're getting both the post information that we need and the user information that we need.
Okay, got it. Thank you.
Okay. So okay, so that's that question. Let's say what if we want to get all of the users that only had one blog post?
Maybe same query, just add like the having clause somewhere.
Yeah. Okay, good. So in thinking about this query, you might notice that, well, this is basically a superset of the information that we actually need, right? So we could probably start here and then try to work our way down. So if we start here, and as you mentioned, to use having. So if you're doing, excuse me, if you're doing like, a regular non-group by query, then if you want to filter something, what's the keyword you use to filter?
Where?
Where?
Yeah, exactly. Where. So where will filter stuff out. When you use a group by, maybe somewhat confusingly, there's a different keyword, which is having. So group by having, and then we can do, so we want count equals 1. We run this, comment this out. Let's see.
Oh, there's just two semicolons.
Oh, thank you. So we drop the excuse me. Work's been pretty brutal the last month, to be honest. All right, so yeah, we we dropped the user. We filtered out the user that didn't meet this criteria. So if we tried to use where here, you can try, but it's not going to work. And you get the usual, almost totally unhelpful error. So that something's wrong, around here maybe. So having. To use group by, you have to use having. And then count. So another, kind of annoying thing that you might run into, if I wanted to alias this, so as total, for example, you're going to want to do something like this, right? So I just basically reassigned it, but that doesn't work. So this these aliases kind of happen at the very end, of the query. So you don't need to really know the details, but you know, you've obviously encountered that you have to write the query kind of in a certain order, and it gets executed in a certain order. And so these aliases get applied at the end. So you would unfortunately have to use this. There is an alternative which you could use. These are numbered, so you could do this, but I wouldn't necessarily. You can't do that here. Anyway, you're basically stuck with this for now. Okay, so let's maybe do. You guys want to do one more, or is that?
Yep.
Okay.
With that, how will, can I ask a question? How will you, like, for example, get the top one? Like the one that has the most posts?
Yeah. So so get the user that has the most posts, for example. So you can do that, but it's going to require basically a subquery, which we could do. Yeah, we'll just do it real quick. You shouldn't need to know this for the assessment, but it's not like, you know, it's not that much different than a normal query. So what information, first off, what tables are we going to need to access?
Post and user.
Yeah, so we're going to need posts and okay, so we need those tables, which means we're going to have to do a
Another
join. Yes, thank you. So join, and then how are these two tables joined?
Would you do join post user ID on blog users.id, just like
Yep.
above?
Exactly. So we can kind of start with the same, you know, we can start by just getting everything and just taking a look at stuff. So select star from blog users, join posts on blog users.id equals posts.id. Okay, cool. We got everything. Wait, did we? So right. So that's a good question. So sometimes it makes a difference what order you do it in, and sometimes it doesn't. So here is an example where it does make a difference what order you do it in. So what's the difference between selecting blog users join posts and selecting posts join blog users?
It's a left join, and blog user only has 3 rows.
Yes. So they're actually both inner join. We've only been doing inner joins so far, but we're starting from all the users here, and there are 3 users. And then we're saying take all the users and then join posts, where the blog users ID equals the posts ID. But we've only got 3 users here, so that's kind of what we're stuck with. But since we actually really, let's see. So we, if we reverse this, we should get what we want here. Hold on. What am I doing wrong here?
Well, should it line 21 post ID?
Oh, yeah, sorry, really dumb. Post dot user ID. My bad, sorry about that. Okay. All right, so we have this join table now with everything there. So we got this join table with everything. So now we want to find out who's got the most. So we can actually do something similar. There's a couple ways we could do this. So I'll kind of do the cheat way first. So we'll join it, blah blah blah, and then instead of just joining, I'm also gonna order by actually, so let's do the whole group by thing. So group by, and we'll do email, comma, account, because you need an aggregate, basically an aggregate column and a non-aggregate column. Do group by, and we're going to group by the non-aggregate column to email. Okay, we're going to group by email, and then what we're going to do is we're going to sort the results. So I'm going to do order by, and the order by is going to be based on the count, and I got to use this whole thing. So order by count, and then by default it'll be ascending. So we'll start with the lowest values, but I want to do descending. So I'm going to specify it. And then let's take a look at those results. So you can see that Bob with a count of 3 is first. So I've joined these together. I've basically aggregated the counts together by email. So I know that I have the counts of everyone. And then I can order that result set, so I can get the kind of extreme I want on top. And then I can limit how many rows I return. So limit 1. So I'm going to run this whole query, but I only want 1 row. And because it's ordered, that 1 row. So if I don't limit, the database is not inherently ordered. So you can't rely on, you can't really like rely on, oh, I did a query on Monday and the first result was X, and so on Tuesday it should be the same thing. So, but because it's ordered, we can know that that is meaningful. So we get the top one that way. Now, if there were a tie or something, if there were multiple people with 3 blog posts, then you would only get one of those 3, and you wouldn't really. You could also order by email as well, but so yeah. So this is kind of a little bit cheating way of doing it, where you just use order by and limit. Another way to do that. So I'm going to take this. Okay, so we're still grouping by email. So we have that result. But what we really want is the kind of we want the maximum of count. So I'm gonna do select max. So we have to do a subquery. And this time I'm going to give it an alias as total. Shortcut. And I have to give this an alias even though I'm not really using it. I'll just call it X. So now I know I can dynamically get the maximum number of blog posts that anyone has made. So with that information, I can then, let's see, I can kind of do this again. Group by email, and then having count equal to and I think this should work. So it's, you know, it's unfortunate that, you know, things can start getting kind of complex. It seems like in some ways it's a simple thing. And I'm sure there's a easier way to do that, but so that's how you have to use. Sometimes you'll use a subquery to dynamically get some piece of information, like the max of whatever. There's also, for this case, we could have used a window function, but I don't want to get into the window stuff. It's more advanced than you'll need to know. But so there's a few ways. There's this, which I showed you, which is a little bit, it's kind of cheating a little bit, but it basically works. There's this where I use a subquery to dynamically get the maximum, and then use that as a in the filter of another query. And then there's also a something called a window, which we're not going to worry about. So if you're you know, frustrated by this query, it's okay. Don't you shouldn't have to do anything like this. Okay. Any questions? So I would suggest, you know, if you're on the fence or not feeling very confident about the assessment coming up on Saturday, just go back to that first exercise where you model like Grubhub, was it Grubhub and Blue Apron and something else. So just look at that. You can look at other people's solutions, try and, you know, try and do it yourself. Create, you know, think about how you're going to design it, create the schemas, input the data, and write some queries.
Hey Chad,
Yeah.
the using with as in SQL, is that like an alias?
Right here
It's something called it's like a with.
with, yeah, that's called the common table expression. And it's again, that's also something you don't need to know for this course, but it's basically like it's basically like a subquery.
Okay.
So you just take a subquery and give it a name, and then you can. I think I haven't really used it for recursion, but I think it's used for like recursive queries. But I'm not 100%. So I've definitely used CTEs just because it's more convenient syntax, because you can kind of take the table and just pull it apart out of everything else instead of having these.
Yeah, I kind of thought it was easier to read than
Yeah,
attempting this, but I was just curious if it does the same thing.
it does. So I would, if I were going to write this query, I would do with, my CTE. Actually, I call it the X. So with X as, and then you would basically just write the query right there. And then in here, you could, instead of basically just take the stuff and put it up there. That's pretty much it. But again, for the rest of you, that's not anything you need to know for the course. Okay, well, if that's it, then I'll let you guys get back to HTTP. Are you guys doing the build your own server today, or is that on Thursday?
Yeah, it's today.
Okay, cool. It's everyone's least favorite challenge, except for the 1 or 2 people who figured it out.
Is that because it's tough?
Oof.
But it's more of like it's more of like background information / hazing. You're not gonna have to actually write a server from scratch. All right, guys. Well, I'm gonna go, but if you have any